Alright, this video is on Chapter 1, Section 7, and we're going to talk about absolute value equations and inequalities. First, you should have seen these before. Two straight bars here are absolute value bars, and absolute value is simply the distance away from 0. And if we're talking about distance away from 0, it's always going to be positive. So if I have the number 5, that is 5 spots away from 0. So the absolute value of 5 is 5. If I have the absolute value of negative 6, I want to know how far away from 0 is negative 6. Well, it's 6 spots away. This is to the right 5, and this is to the left 6. And 0, well, 0 is on 0, so it's going to be at 0. Just remember that absolute value is always the distance away from 0, and it's always positive. So we don't consider the direction in which you're moving. So if I want to solve, I want to find out what number did I take the absolute value of to get 5. Most of you are sitting there thinking, yes, I know it's 5. But that's not the only answer. Your answer could be a positive 5 or it could be a negative 5. Because if I took the absolute value of 5, yes, I get 5, that's 5 spots away. But negative 5 is also 5 spots away from 0. So that number inside those absolute value bars could have been a positive or a negative because the absolute value cancels out that negative sign. So here I want to know what number gives me the absolute value of a negative 2. So you may be thinking, all right, negative 2. I take the absolute value of negative 2. Well, that's 2 spots away, so I get a positive 2. So you try a positive 2. Well, that's also 2 spots away. This has no solution because remember we said absolute value is always positive. Alright, next one we've got the absolute value of x minus 3 is equal to 15. So this number, this entire number inside the square root, we want it to give us an answer of 15. Well, that whole quantity could equal a positive 15 or it could equal a negative 15. Because remember, the absolute value bars get rid of that positive or that negative. Just like here, this number could be a positive 5 or a negative 5. This whole piece, this whole quantity of x minus 3, that could equal a positive 15, giving us absolute value 15, or that piece x minus 3 could give us a negative 15, leaving us with a positive 15 once we evaluate that absolute value. So I've got two possibilities, positive 15 or negative 15. We solve for x, and I get x could equal 18. Add 3 to each side, and we get or x could be equal to a negative 12. We have two possibilities, and to show you where that comes from, we just plug it back in. If I plug in 18, I get 18 minus 3. I get the absolute value of a positive 15, giving me 15. If I plug in negative 12, I get negative 12 minus 3. Well, that gives me the absolute value of a negative 15. And the absolute value of a negative 15, that's still 15 spots away. So I still get a positive 15 as my answer. Go ahead and try the next one on your own. We want to find out what value or values of x will give me an absolute value of 9. Press pause, and when you're done, press play and see if you were correct. Alright, so we set up two equations. 2x minus 5 equals 9 and 2x minus 5 equals a negative 9. Remember, we're not saying that the absolute value is equal to a negative 9. We're trying to find that value of x that's going to make that equation be a negative 9. Because when I evaluate this absolute value of a negative 9, I still get a positive 9. So the two values that you should have found were 7 and negative 2. If you didn't find those two numbers, make sure that you're pausing and you're checking all of your work with my work to see where you made your mistake. Alright, we are going to now combine the idea of absolute values with what we talked about yesterday with inequalities. So we're going to fuse those two things together. When you are solving absolute value inequalities, we talked about a couple different signs yesterday. We said less than or equal to, or greater than or equal to 2. And we know that this was an open circle and these two were closed circles. But what you need to know in addition to that for today is we're going to have compound inequalities. And if I have compound inequalities, I need an and or I need an or statement between those two. So with equations, we set up two equations. Now that we have inequalities, we're going to set up two different inequalities to give us that compound factor. So we're going to solve. If you have a less than or equal to sign, just think less than, and we're going to kind of fudge that a little bit, and this is going to be an and compound inequality. So anytime you have a less than or equal to, it's less than, and you have an and compound inequality. Here you've got greater than or equal to. So we're going to change our spelling just a little bit here. Instead of greater, we're going to change the E to, and we're going to say greater. And you see that you have an or compound inequality. So kind of a little trick, think about what you're saying, which one's closer, and or. So when we approach our first problem, we've got 2x plus 7, the absolute value of 2x plus 7 is less than 11. So right off the bat, so I don't forget, I write down that this is an and problem. And we are going to set up our two inequalities. So we're going to take the first one as is, dropping the inequality sign, or the absolute value sign. So we've got 2x plus 7 is less than 11. Now above with our equations, we had that equals 15 and that equals a negative 15. We've got actually two changes to make with absolute value inequalities, not just changing the 11 to a negative 11. So we've got the and, we rewrite the 2x plus 7. We are going to change it to a negative 11, but in addition to changing the negative 11, we're going to change it from a less than to a greater than sign. So two changes. First inequality, you take what you were given, just drop the absolute value signs. For the second one, you flip the sign and then change it to the opposite. So since we have positive, we change it to negative. If it was negative, we change it to a positive. And then we go ahead and solve. We move our 7 over. We've got 2x is less than 4, divide by 2, x is less than 2. Bring down our word and so we don't forget. Move our 7 over. 2x is greater than negative 18, divide by 2, and we've got x is greater than negative 9. Now we're not going to flip the sign there because we didn't actually divide by a negative. Now if this was a negative 2, we would flip. We had a negative in the problem, but the actual piece that we were dividing by wasn't negative. So we set up our compound inequality graph. We've got two numbers, 2 and negative 9. Negative 9 is smaller, so that goes to the left. 2 is larger, so it goes to the right. We've got x is less than 2. Less than means open circle to the left. Greater than negative 9. Open circle to the right. Now because we have an and, we are looking for the overlap. What do they both have in common? And that's all numbers between a negative 9 and a positive 2. Alright, moving on to the next one. We've got a greater or equal to 8. So we know that this is going to be an or compound inequality. We set up our two mini inequalities. So we've got 3x minus 2 is greater than or equal to 8. Remember, it stays exactly as it is. Just drop the absolute value bars. Or 3x minus 2, the left-hand side doesn't change. We flip our sign to less than or equal to, and then change it from a positive 8 to a negative 8. Move our 2 over. 3x is greater than or equal to 10. Divide by 3. And we get x is greater than or equal to 10/3. So remember, it's okay to have fractions. Our second one, we add 2. 3x is less than or equal to a negative 6. Divide by 3. And we've got x is less than or equal to negative 2. And we've got an or problem here. So we've got two numbers, a positive 10/3 and a negative 2. The negative is smaller because any negative number is smaller than a positive, so we go to the left and 10/3 to the right. We've got greater than or equal to, which means we've got closed circle to the right, about 10/3. Less than or equal to a negative 2, closed circle to the left, And if you remember, or means combine or recopy. So I'm going to recopy both of those. And yes, you must actually recopy and redraw them. If you just leave the first two, you will lose your point for your answer. I recopy both of them above, showing me that I combined the two sets together. Next, we've got less than 6, which means we've got an AND problem. And I'm going to set it up with my two many inequalities. So I've got a negative x plus 5. Let's put this in blue. Is less than 6. Remember, we just dropped the absolute value bars. And then we set it up again, the left staying the same, changing the less than to a greater than, changing the positive to a negative 6. Move the 5 over. Negative x is less than 1. Now, we don't want to solve for x, or negative x, we want a positive x. So we have to divide by a negative 1 on both sides. Now, this time I actually multiplied or divided by a negative, so I've got to flip that from a less than to a greater than. So x is greater than negative 1. Go to our second inequality. Negative x is greater than negative 11. Divide by the negative 1, and we get x is less than 11. Go ahead and move to our graph. We've got a negative 1 and a positive 11. Well, negative 1 is smaller because it's negative. And then we have 11 on the right. So we've got greater than negative 1, open circle to the right. Less than 11, open circle to the left. And means we are doing our overlap. So we're going to see where those two lines overlap each other. What do both sets have in common? And it's a range of numbers between a negative 1 and a positive 11. Alright. We're almost there. Alright, so we've got greater or equal to 0. So we've got an or compound inequality. We set up our 2x plus 6 is greater than or equal to 0. Or 2x plus 6, we've got to switch the sign. Now the only problem here is we can't do the opposite because 0 is neutral. There is no positive or negative, so we just keep that as 0. And we go ahead and solve. So 2x is greater than or equal to negative 6. Divide by 2. And we get x is greater than or equal to a negative 3. Moving over, we move the 6 over. So we've got 2x is less than or equal to a negative 6. Divide by 2. And we've got x is less than or equal to negative 3. So we set up our graph. And we only have one number this time of negative 3. Our first one is greater than or equal to. So we've got a closed circle to the right. Less than or equal to. Closed circle to the left. And we want to combine those. So we combine every number in this set and every number in that set. And when I recopy them, I realize I've counted for all of my numbers. The first one's for my large ones, this one's for my small ones. So we've got a special case here. This is all real numbers. So any case there is going to make that true. And that should make sense because absolute value will always be a positive number, which means that no matter what a number I put in there, it's always going to be larger than 0 because positive is always larger than 0. Now, this is our last problem that we have to solve and work out for, so you know the drill. I want you to pause, try it on your own, press play when you're done, and see if you're right. Alright, so you should have solved and got x was less than or equal to 4/3, and x was greater than or equal to 14/3. When you set it up, 4/3 is smaller than 14/3. It's an AND problem. You're looking for overlap. There is no overlap, so there's no solution. Now, we've got two special cases here, and I want you to think about what it actually means. So always think about the problem that you're given, and does it make sense? So if I've got the absolute value of x minus 5 is equal to negative 2, this must be positive, so this is not possible. So that's no. That would be a no solution. Here is x minus 5, which again, this has to be positive. Is that going to be greater than negative 2? Yes, that's always, because positive is always going to be greater than a negative. And last, if this is positive, is that going to be less than negative 2? No, it's going to be greater than, because this is always going to be a positive number. Always think about your answers and whether or not they make sense.